Hello my test student, welcome to another step preparation video. Today we'll be going over 2019 step 1 question 8. I think out of the whole paper this is definitely my favourite question. It's just the study of a completely new to us function and what happens when you apply a bunch of stuff. Do excuse the already written over stuff here. I started filming this and then I was like, no, that's super bad, so I stopped again now. Anyways, for part 1, I think the only difference is the 2 instead of the 1 here and the two twos instead of the ones here. So a pretty straightforward start would be to replace u with 2t. So u equals 2t, then t equals u over 2 and du by dt equals 2. So du equals 2. This gives me the integral from 2 to x of root u minus 2 over u plus 2. Du is equal to the integral from 1 to x over 2 times 2t plus 2, 2t minus 2 is just 2t minus 1 over 2t plus 1 times 2 dt, because that's just du here. If you don't like how I integrate by parts, just do it yourself with the same substitution. I do it in a relatively specific way. I know a lot of people do it differently. I know a lot of people do it in the same way. It's just, it doesn't matter. Everybody does it their own way. Everything's good. And this gives me 1x over 2 root t minus 1 over t plus 1 dt. And this is just the function of, instead of it being up to x, it's up to x over 2, and there's a factor of 2 in front of it, so that's just 2f of x over 2. Yay! For part 2, I see a difference between the top and the bottom of 4, and here I see a difference of 4, so I'm thinking it's just the function that I have here, the function that I've derived here, shifted over by a constant. I'm going to check that by letting u, for part 2, u equals v minus 2, so that our numerator is going to be the same as it was in part 1. This gives me v is equal to u plus 2, and the u equals dv. Then I have the integral from 0 plus 2 to 2x plus 2 of root v plus 2, sorry, v minus 2, and then u plus 4 is going to be v minus 2 plus 4, which is v plus 2 dv. And this, as specified earlier, is going to be 2f of half x, here x being x plus 2 because the limits are the same here. So that's going to be 2f of a half of x plus 2, a half plus 2, which is 2f of a half x plus 1. For part 3, you might try to use the same substitution, same type of substitution, to get u minus 5 is equal to v minus 2, so that you have the same integral as you have in part 1. However, you'll soon realize that no matter what you do, you'll never be able to have the same numerator and the same denominator at the same time, and that's because the difference between the numerator and the denominator is this time 6, not 4. So when the difference was 4, the key was to convert it to u minus 2, u plus 2. So how about we can try converting it to u minus 3 over u plus 3. This would give us u minus 5 equal to v minus 3. So u is equal to v plus 2 v equals u minus 2 and du equals dv. Plugging it into the integral, we have the integral from 5 to x of u minus 5 over u plus 1 du equals the integral from 3 to x minus 2 of the square root of that's going to be v minus 3 over u plus 1 is v plus 2 plus 1 v plus 3 d v. Now we already have experience with converting integrals of the form u minus constant, u plus the same constant, into t minus 1 over t plus 1. Here we use the substitution u equals 2t. So here, because it's minus 3, we might as well try the substitution v equals 3t. Trying this, we have also dv equals 3 dt, giving us 3. So that's the integral from 1 to x minus 2 over 3 of 3 of t minus 1 over 3t plus 1 times 3 dt equals 3 times the integral from 1 to x minus 2 over 3 of root t minus 1 over t plus 1 dt, which is exactly 3f of x minus 2 over 3. For those of you wondering why I don't have tip-top sheets of paper, there's stuff written here, it's because waste is bad. Also, these are actually the sheets from my real set of paper. So lucky you. Now, I'm just going to check that everything's aligned. For integrating this, when I did this in timed conditions for practice, I actually found it really hard because I thought there's no way that a u squared not under a square root and a u squared under square root can possibly become of the form of both u's being under square root. Turns out, if you just do the simple substitution, u squared equals v, everything works out. So, using that, I have dv equal dv by du is equal to 2u, so du equals 1 over 2u dv. Just applying this gives me the integral from 1 to 2 squared, so that's 4 of u squared over root v plus 4 d times 1 over 2u dv, which is equal to a half, integral from 1 to 4 of u over root v plus 4 dv, which is equal to a half, integral from 1 to 4 of root u over v plus 4 dv. Looking at what we have over here, this is pretty much of the same form. We have an integral not from 0 to x, but from 1 to x. So this could just be the integral from 0 to 4 of this thing, minus the integral from 0 to 1 of this thing. So I'm going to do exactly that, or rather I'm going to, fine, I'll do everything. 0 to 4, a half integral from 0 to 4 root, that's v over v plus 4 dv minus a half integral from 0 to 1 of root v over v plus 4 dv, giving me each of these was 2f of x over 2 plus 1. So this is going to be a half times f of 4 over 2 plus 1, 3. Sorry, a half times 2f of 3 minus a half times 2f of 1 over 2 plus 1, 3 over 2. Gives me 2f of 3 minus 2, sorry, not 2 because there's a half here, so that's f of 3 minus f of 3. There we go. I hope you guys enjoyed this video, and I hope also that your exams go perfectly well.